Hello and welcome. Today we're going to do Tinkercad kit number 1. To start, you'll open MATLAB. Hopefully you followed my tutorial in the last video that showed you how to get your Tinker code in the correct spot. Once you have, go ahead and open up Blink 1 LED, or excuse me, Blink and LED MLX, and it should pull up something that looks similar to this on the right hand side. We will be using your Arduino, the breadboard, and a 333 resistor today. These are the ones with the orange, brown, gold stripe on them. Read through here. One of the first things you will need to do is actually connect your Arduino to the computer. The easiest way to do this is to figure out which port it uses. So you're going to right click on the start menu. You're going to click on Device Manager. Once this pops up, we will go down to Ports, right here, Ports COM, and I can see that I have something plugged into COM port 3. If you've got a few things plugged in, you may have to have a little bit of trial and error here, but typically it will be the last port plugged in or the highest number. Once you have your COM port figured out, open up your command window and you're going to type in something very similar to this. A equals, A is the variable we're setting, Arduino, this lets it know what we're using, parentheses, apostrophe, COM3, apostrophe, comma, apostrophe uno, apostrophe, parentheses. Make sure you get those apostrophes in there. Without those, it won't work, and it needs to be in this order. Once you have that, hit enter. This will take a minute to connect to your Arduino. The first time you do this, this may take a couple of seconds. Once you're connected, it should turn on, and you should see something similar to this. Your Arduino should be connected. You'll see a green light indicating that it's working. Right, back to our Tinkercad here. We're going to go down and we're going to set up our Arduino. So let's talk about the Arduinos real quick for a moment. Today, we will be using the digital ports found on the right-hand side, and we will be using a ground labeled G and D. These ports here can easily be connected to using some of your included jumper wires. They simply slide into the port, and then you can connect it to the included breadboard. We'll talk more about that in a moment. Quick note about your circuits. As you build your circuits, you'll use more and more jumper wires. For your own sanity and my sanity, please do not use all the same color to build your circuits. Convention in this case is red is for power, black is for ground. And any of our other colors here work best for creating the circuits. On the breadboard, you should have something like this. You can see I have a resistor already placed in there. Breadboards are simple devices that allow us to quickly create circuits without having to solder anything. These are fantastic temporary connections. You'll notice on your breadboard, along the sides, there are some lines that go from top to bottom along the columns. This red and black, these common rails are all connected. What that means, if I plug a wire into one of those, and I plug a wire into another one, these are connected. Typically, we will put power into the red one and ground into the black one. This allows us to have one power connection coming into our breadboard to the Arduino, and one ground, which will become very important later, and then connect that anywhere we need in the circuit. Next, you'll also notice, in this case, I have a resistor plugged in here. Along these rows are also common. So any of the numbers here, 1 through 30 on yours. So let's say 10. 10, A, B, C, D, and E are all common rails. What that means is that they connect all the way across. In the center, we have a break here. Nothing goes across here. There is no power connection, no shared rail. And then on the other side, it picks back up. So 10, F, G, H, I, J are also shared. What this allows us to do is take something like an LED or a resistor and connect from one side to the other. And then we can have power and a ground. And this isn't quite the right circuit. I'll show you why in a minute. We're going to include this resistor in here, but this is an example. Now let's go back to our MATLAB code and go over the basics there and how we're going to test to make sure our Arduino is actually connected right. Back in our space here, take a bit to read through these write-ups. They're very good write-ups and explain quite a lot about how we're going to work with our Arduinos. Now, this is a circuit diagram. These are very important. We will be using these quite a lot. In this case, we're going to follow this tutorial exactly. So we're going to connect a yellow wire from pin 13 up to 2. I'm going to do this on the side where you cannot see me yet. So we're going to connect from pin 13 up to 2. We're going to take our LED. Now, if you read through the instructions, the long wire is the positive, the short wire is the negative. And if for some reason it's ever cut, the short wire, the ground, will have a flat spot. I don't know if we can see that. It has a flat spot on the side of the LED that you can feel. We're going to connect the long wire to the same rail as the resistor. Once again, this is one of your 333 ohm resistors. And in this case, they actually go from 2 to 1. And then we're going to take a black wire denoting ground. We're going to go from 1E back to ground. Now, a common failure in circuits, especially these Arduino circuits, is getting your wires plugged into the wrong port. Take a minute and double check. These are tiny little holes on here. It's really easy to move them up or down one and be in the wrong port and not have anything work, especially with a ground connection. So double check that. Let's see. For that, we're going to continue down through here. We've already connected our Arduino, but once we get to this part, this is the actual code. And you'll see a couple of things here. First, we define a variable. MATLAB is nice in and of the fact you can define variables as anything anywhere along the line. That's usually cleanest to put at the very top of your code, like this. This is a fantastic example. LED pin equals D13. Make sure that it looks just like this. You are not going to have to copy this or write this right now. We'll get into writing code later. But I just want to go over what everything is. Down here, it goes into a while loop. While loop, it will just continue as long as something is true by saying 1. Nothing changes 1, so it's always true and it will just run forever. Write digital pin. It's just telling it to turn something on or off. A is the variable that we already defined earlier. It's the Arduino LED pin, which we defined right here. And 1. 1 is on, 0 is off in electronics. So it turns pin 13 on. It pauses for 2 seconds. Write digital pin, same thing as above. A LED pin 0. This turns it off. And then it pauses again. And then ends. And then it loops back to the beginning. If you click on this blue bar right here, it will run your code. And we're going to test that here. Everything worked right. You should have some blinking lights on your Arduino. And if it didn't work right, you'll get an error. Errors are common in any programming language. I'm going to figure out what that is real quick, and then we'll be right back. And we're back. Okay, so this particular error pops up in MATLAB occasionally, and I want to cover what's going on here. I cleared out my variables and then reconnected to my Arduino before we started. Occasionally MATLAB gets grumpy about that. If you had a circuit that was previously working and you clear your variables, something you'll do later, and you reconnect to your Arduino and nothing seems to work, the easiest way to resolve that is to save your code and restart MATLAB. We just haven't found a good way to go around that otherwise. But anyways, we're back, restarted the code. Now that we're back, if you click on this blue bar right here, it will take a moment and it will start flashing on your Arduino, assuming everything's gone right. And you should see the LED turn on for a couple of seconds and turn off for a couple of seconds. You'll also see an LED on your board. Pin 13 has an onboard LED. This is a great way to quickly check and make sure that your Arduino is actually working. So it should flash at the same time. If you see this blue LED flashing, but your circuit over here, your LED is not flashing, check to make sure your wires are in the correct ports, and make sure that your LED is the right direction. There's the basics of Kit 1. But let's go further. Let's see what else we can do. You go back to your MATLAB. You'll notice there's a pause and a start button over here. You can use these if you want, but a good hotkey is Control C. Control C will stop your program, assuming you are in the program. But the stop button works just as well. Now we're going to make some changes to this code. It is bad practice to change the code in here. Well, you can do that. Later in some of your other kits, this will get unwieldy. So what we're going to do is we're going to copy and paste. I'm only going to go through the LED pin right here. However, you can go the whole way up. I wouldn't copy everything, but you can get any of this comments here. By the way, anything after a % is a comment. The Arduino and MATLAB will not read that. That is there just so you know what's going on. We're going to create a new file and bring our information into it. So we're going to go up here and click on New. And in this case, we just want a normal script. We don't need a live script. Live scripts are what you're actually looking at right here. They allow you to embed pictures and other things. We're just going to make a straight script. So it'll pop up here. Number 1, blinking cursor. We're going to paste it in there. I just Control V. And you should see something similar to this. We're going to test this, make sure it works. Click Run. The first time you run a Tinkerkit, a MATLAB file, you'll have to name it. So this is Tinkerkit 1. It will take a moment and go, and you should see your Arduino blinking away. Okay, so now that we know our copied code works, let's make some changes to it. So the first thing we can do is maybe change the time. I'm always a big fan of making these smaller, so I'm gonna go ahead and make this blink fast. Also, you will see that it hasn't actually stopped running. Oops. Down here. There we go. Okay. So now we're going to run it. It uploaded just fine. And let's prove that it's working. And you can see it now blinks rapidly. Play with this a little bit and you can achieve some interesting patterns. But let's go even a little further than that. Okay, so here you can see that I've modified my circuit a little bit. Let's take a closer look at that. Now, this is where the breadboard becomes very useful, and this is where wire management also becomes important. But let's go from one side of the circuit to the next. As you can see, I've used 3 different color LEDs, and they're plugged in very similar to how your red LED was. I just copy that over. We are using the same 330 ohm resistors for all of these. I made a slight change here. As you can see, circuits get a little interesting. Instead of running the black wire straight to my Arduino, I actually ran it to the common ground here. And then I have one wire from the common ground to the Arduino. This way they all share the same ground. And then I have three different colored wires going from digital pin 13, 12, and 11 on the Arduino. And let's take a look at the code, see what we did to change that. So over here, there's a couple of important things that happened. Changed the code just a little bit. You will notice instead of just LED pin, I changed it to LED pin R, and I added pin B and Y. Your variable should be something that makes sense to you and is readable and understandable. I also defined them as the according pins. D13, this is the same one we used before, D12, and D11. Now down here, because we made a change to the name of the variable, I had to go ahead and change this name right here, which variable we're using, to LED pin R. And then I simply copied and pasted my code below it and changed the variable names down here. So LED pin B and LED pin Y. MATLAB does not mind if you put spaces in your code. This is actually quite advisable, so it's readable. Also, feel free to put in comments as you go. Deep. This way you can come back later and read what you wrote. A super common problem with programming is you will understand exactly what you're doing when you're doing it, or mostly exactly what you're doing. And you'll take a break and you'll come back and you won't understand what you've done. Take advantage of this comment tool to write notes to yourself and anybody else like me who may have to read your code. Anyways, we go through and you can see the different times which made the LEDs blink in different in an order. You notice it goes from top to bottom here. Take a while and play with this, see what you can come up with, and there you go. That is the beginning of Tinkercad, Tinkerkit 1. I hope you guys learned something and had fun. We'll see you later.